Picture a multi-billion-dollar artificial intelligence robotics lab. Just take a second and visualize the space where the most advanced machines in human history are being built right now.
You're probably imagining like these incredibly sterile, brightly lit white rooms, right?
Exactly. Yeah, you picture millions of dollars of humming server racks lining the walls, maybe a small army of Silicon Valley engineers in, expensive hoodies monitoring telemetry on glass tablets.
Right. The ultimate picture of high-tech exclusivity.
But the truth is, the future of humanoid robots, the machines that will eventually be navigating our homes and offices, it isn't being forged in those pristine ivory towers at all.
No, not even close.
It's actually being built in a cramped, messy studio apartment in central Nigeria, guided by a medical student with an iPhone strapped to his forehead.
It is wild to think about.
It really is. So we are looking at this fascinating piece of reporting from MIT Technology Review, which surfaced in a recent AI News Digest, and it just completely shatters our assumptions about how machine learning works in the physical world. Okay, let's unpack this.
Yeah, so what we are witnessing right now is a fundamental paradigm shift in what the industry calls embodied AI.
Embodied AI.
Right. Because for a long time, artificial intelligence was basically just a brain in a jar. Software analyzing text or generating images on a server somewhere.
Right. It didn't have to deal with the real world.
Exactly. But the moment you decide to put that AI into a physical body, one that has to actually interact with gravity and friction and, well, messy human environments, the whole development process has to migrate.
It has to leave the lab.
Yeah, it migrates away from those controlled tech environments and moves directly into the global gig economy. We're transitioning from the theoretical physics of robotics to this intensely practical, boots-on-the-ground reality of human living spaces.
So to really wrap our heads around how this migration is actually happening, we need to zoom in on one specific individual highlighted in the source material.
Yeah, let's look at the visceral reality of this.
Right. We need to leave the abstract concepts behind and look at a guy named Zeus. He lives in a hilltop city in central Nigeria, and his primary occupation is actually as a dedicated medical student.
Which is an incredibly demanding job on its own.
Totally. Think about the grueling reality of that life. You are on your feet all day, running around a hospital, dealing with high stress, literally life or death situations.
Yeah.
So the source describes Zeus coming home to a studio apartment after this draining hospital shift. But instead of, collapsing on the couch like most of us would, he begins his second shift.
And that second shift involves stepping entirely into the virtual supply chain of robot training.
Right.
He essentially transforms his own living space into an active data generation node for some of those highly valued tech companies on the planet.
And the setup he uses for this is what really caught me off guard. If we are talking about building a sophisticated, autonomous, humanoid robot, my brain immediately defaults to assuming the training equipment must be just as sophisticated.
Oh, absolutely. You'd think it would be top of the line.
But Zeus's setup is entirely DIY. He just sets up a ring light, straps his own personal iPhone to his forehead, turns on the camera, and just starts moving around his apartment.
Just a guy and his phone?
Yeah. I was trying to map this onto something familiar like Hollywood's CGI. When they want to capture human movement for a digital monster in a blockbuster movie, they use a massive motion capture studio.
Right, the ping-pong ball suits.
Exactly. They put an actor in a skin-tight suit covered in hundreds of those little sensors and surround them with dozens of specialized infrared cameras in a multi-million-dollar facility.
Yeah.
But here, we are trying to achieve an arguably much more complex technological feat, and the entire motion capture process has been reduced to a consumer smartphone strapped to a guy's head.
It's crazy when you put it like that.
I understand that cameras have gotten really good, but how does an outward-facing phone on his forehead capture his body movement? It can't even see his legs.
Well, so that is the crucial distinction between Hollywood motion capture and embodied AI training. In Hollywood, the mocap suit is literally mapping the physical joints of the body to animate a 3D puppet.
Okay.
The engineers there already know how the alien is supposed to move. They just need the actor to trace the lines for them. But the AI developers employing Zeus aren't trying to map his body at all.
Wait, they aren't?
No, they are trying to map his brain's decision-making process. The iPhone on his forehead acts as the robot's eyes and inner ear. It is recording the world from the exact height and perspective the robot will eventually have.
Oh, I see. So it's capturing the visual input, like what the robot will actually see. But how does that teach it to move its physical legs?
It's all about reverse engineering the kinetics.
Yeah.
The modern smartphone is packed with sophisticated sensors. It's not just taking a video, right?
Right, it's got a bunch of other stuff in there.
Yeah, it's using LiDAR scanners to map the three-dimensional depth of the apartment in real time. It uses an inertial measurement unit, or IMU, which includes accelerometers and gyroscopes.
So it's tracking every tiny movement.
Exactly. As Zeus walks, the IMU records the exact kinetic forces of his head bobbing, the micro impacts of his heels striking the ground, and the subtle shifts in his balance as he navigates around, say, a chair.
Wow.
And then the AI models take that incredibly dense telemetry and basically work backward. If the head moved in this specific stable trajectory while avoiding an obstacle, the AI calculates the micro adjustments the hips, knees, and ankles must have instinctively made to keep that camera stable.
That is fascinating. So Zeus isn't just showing the robot how a leg bends.
No, he is providing the raw data of how a human mind intuitively processes space, gravity, and momentum.
Okay, I want to push back on the logistics of this, though. Let's play devil's advocate for a second.
Sure, go for it.
We are talking about massive tech companies with virtually unlimited budgets, right? If they know they need this specific kind of spatial and kinetic data, why don't they just build a massive, messy apartment simulator at their headquarters in Silicon Valley?
Right, why not just do it in-house?
Exactly. They could hire 50 actors to wear top-of-the-line sensor suits and walk around a giant warehouse filled with fake living rooms. Why go through the trouble of hiring gig workers in central Nigeria or anywhere else to use their own iPhones?
It comes down to the inherent problem of entropy, or what engineers often call the long tail of reality.
The long tail of reality.
Yeah. Think about it. If an engineer in Silicon Valley designs a simulated messy room, it is still, fundamentally, a room designed by an engineer.
Oh, I see where you're going with this.
Right. They might throw some laundry on the floor and put a coffee table at an awkward angle, but it will still be logical. The lighting will be relatively uniform. The materials will be standardized.
But real life isn't like that.
Not at all. The real world, the world where a humanoid robot will actually have to operate, is infinitely chaotic.
Right.
It is full of unknown unknowns.
You mean things the engineers wouldn't even think to program into a simulation?
Exactly. Real life has weird reflections coming off a warped bathroom mirror. It has a sudden change in floor friction because a patch of hardwood is slightly damp from a spill.
Or a narrow hallway filled with an unpredictable stack of moving boxes.
Yes. By distributing data collection out into the global gig economy, these companies harvest true spatial entropy. They gain a diversity of lived-in environments that money literally cannot simulate in a single facility.
Wow, okay.
So when a company hires Zeus, they aren't just buying his movement data. They are buying the unique, chaotic spatial constraints of his specific studio apartment. They are capturing how a human adjusts their stride to step over a slightly raised threshold that was, installed poorly 30 years ago.
I see. So the multi-million-dollar labs are actually a handicap for this specific stage of development because they lack friction. They are just too perfect.
Precise.
If you train a multi-million-dollar robot exclusively in a pristine testing facility, the moment it encounters a genuinely messy living room with a weirdly shaped rug, it'll just completely freeze up because it's outside its distribution of training data.
And that is the core argument of the MIT Technology Review piece. AI development has hit a wall where throwing more server racks at the problem just won't solve it anymore.
They need the messiness.
They desperately need the chaos of the real world. And the gig economy provides this highly scalable, decentralized way to sweep up all that real-world chaos and feed it into the machine learning models.
Well, let's focus on the actual labor happening in that room then, because what Zeus is physically doing with that iPhone strapped to his head is fascinating in its simplicity.
It really is.
According to the source, the tasks he is contracted to perform involve things like walking in specific patterns, picking up objects, or just repeatedly raising his hands. He is essentially pacing around his apartment.
Yeah, doing chores, basically.
Right. If you were looking through his window, it would look incredibly mundane. It might even look completely pointless.
On a purely visual level, it is completely mundane. But we have to analyze why an AI company is willing to pay for hours of data of a man simply walking back and forth.
And that is where the math really confuses me. Because we have self-driving cars that can navigate four-way intersections at 60 miles an hour while tracking pedestrians and other vehicles.
Right.
We have language models that can pass the bar exam. Why is a human walking around a coffee table at 2 miles an hour causing such a massive bottleneck for the most brilliant engineers on Earth?
Well, you've just stumbled onto one of the foundational concepts of artificial intelligence, It's known as Moravec's paradox.
Moravec's paradox, what is that?
In the 1980s, roboticists like Hans Moravec discovered a really counterintuitive truth about how machines learn. They realized that high-level reasoning, things like playing grandmaster-level chess, doing calculus, or passing a standardized test, requires relatively little computational power.
We really?
Yeah, for a machine, it's just symbolic logic.
Mm-hmm.
But low-level sensoromotor skills, things like keeping your balance, walking up a flight of stairs, or recognizing a cup and grasping it without crushing it, those require immense, almost incomprehensible computational resources.
Because humans do those physical things without actively thinking about them. Like, a toddler can walk across a room, but a toddler obviously can't play chess.
Exactly.
Yet, for an AI, the chess is easy and the walking is nearly impossible.
Precisely. Because we have hundreds of millions of years of evolution acting as our back-end software.
Oh, that makes so much sense.
When you walk, your brain is instantly calculating the tension of dozens of muscles, adjusting for the squishiness of the carpet, the slight tilt of the floor, and the swinging momentum of your arms.
All while keeping your head perfectly level so your vision doesn't blur.
Exactly. You can't just write a mathematical equation that tells a robot how to do that naturally. You cannot program human intuition line by line.
So the only way to teach the machine is by feeding it an overwhelming volume of raw examples, like millions of hours of human kinetic data.
Yes. When Zeus raises his hands or walks in a figure-8 pattern in his apartment, those sensors are capturing the raw physics of evolutionary biomechanics.
Wow.
The machine learning system analyzes his mundane pacing and starts to recognize the deep patterns of human balance. The goal isn't just to teach the robot the mechanical function of moving a metal leg forward.
It's deeper than that.
Much deeper. The goal is for the robot to internalize the nuance of human movement so it can eventually integrate into our spaces safely and naturally. The robot is literally learning physical intuition by absorbing the micro-movements of a medical student in Nigeria.
You know, that completely reframes the narrative around AI for me. Whenever artificial intelligence is discussed, whether it's on this show or in mainstream media, it is almost always framed as this top-down, unstoppable wave.
Yeah, like it's just happening to us.
Exactly. It's presented as this monolithic force handed down from the tech giants, and the rest of us just have to brace for impact. But the reality outlined in this source material completely subverts that.
It really does.
The cutting edge of robotics isn't just happening to us, it is being built by us. It's a blend of high-tech algorithms and ground-level, grassroots human effort.
It represents a profound democratization of data generation. The future of the physical AI economy is no longer solely in the hands of a small demographic of engineers in one specific region of California.
Right, it's global now.
It is literally in the hands of the walking patterns of everyday people participating in the global gig economy.
And if we follow that logic, it opens up an incredibly fascinating implication which the source material touches on, and I really want us to dissect.
Oh, I know where you're going with this.
Right. If the foundational behaviors of tomorrow's robots are being crowdsourced from a truly global workforce, from people in Nigeria, the United States, Japan, Brazil, are we just teaching them to walk, or are we teaching them to walk like us?
Yeah, that is perhaps the most compelling question to come out of this whole shift toward gig economy training. Human movement is not universally standardized.
Obviously not.
We all share the same basic biomechanics, sure, but how we use our bodies in space is deeply influenced by our culture, our environment, and our architecture.
Let's break that down. What does a cultural physical accent look like in a robot? If an AI model is trained primarily by gig workers living in tiny, densely packed apartments in Tokyo, how does that translate into the machine's behavior compared to, say, one trained by workers in sprawling suburban homes in Texas?
Well, it manifests in what sociologists call proxemics.
Proxemics.
Yeah, the study of personal space and how we interact with our environment. A robot trained heavily on data from densely populated urban centers where living spaces are compact will likely learn to navigate with much tighter margins.
Oh, wow.
It might keep its limbs closer to its core, make sharper, more efficient turns, and inherently understand how to gracefully step out of the way in a narrow hallway simply because the humans who generated its data constantly had to do that.
Whereas a robot trained in an environment with wide-open floor plans might move with broader, more expansive gestures.
Exactly.
It might take longer, sweeping strides, and naturally leave a wider radius around objects and people because the gig workers training it never had to micromanage their personal space in their own homes.
And beyond just navigating architecture, it bleeds into how we gesture and interact with each other. Think about the speed at which people walk in different regions, or how they hand an object to another person.
Right, those little social cues.
Does the robot learn a subtle nod of acknowledgement when it passes you in the kitchen? Because the workers in its dataset naturally did that when their phone cameras captured family members walking by.
That is so interesting.
By relying on global gig workers like Zeus, AI companies are inadvertently vacuuming up the cultural idiosyncrasies of human body language.
So we might eventually see humanoid robots that have distinct physical accents based on the dominant data sets they were trained on. Like a robot could have a Nigerian spatial awareness or an American gestural cadence.
That's entirely possible, yeah.
That is wild. It means these machines aren't going to be blank, sterile appliances. They're going to be a composite mirror reflecting the incredibly specific regional quirks of the people who work the second shifts in their studio apartments to bring them online.
It proves that technology is never truly objective. Even when we are dealing with cold steel, silicon, and complex mathematical algorithms, the final product is inextricably linked to the messy, diverse reality of the humans who provided the source material.
Wow.
The robots of the future will carry the kinetic signatures of people like Zeus.
It really makes the world feel strangely smaller and, infinitely more interconnected. Well, let's briefly recap the journey we've taken through this deep dive.
Let's do it.
We started by breaking out of the sterile, multi-million-dollar Silicon Valley tech labs and traveling to a hilltop city in Nigeria to meet a medical student pulling a second shift with an iPhone on his forehead.
Quite the shift in scenery.
Yeah, we examined the massive industry pivot away from controlled environments, discovering that tech giants actually need the unpredictable entropy of the global gig economy to teach machines how to handle the chaos of the real world.
Right.
We tackled Moravec's paradox, breaking down the mechanics of why the seemingly mundane acts of pacing around a room are actually the secret to translating biological intuition into machine learning. And finally, we explored how this grassroots approach is actively democratizing AI development, raising the fascinating possibility that tomorrow's robots will inherit the diverse cultural body language and physical accents of the global workforce that trained them.
And as we close out our analysis of this MIT Technology Review article, I want to leave you with one final thought to mull over, building on that whole idea of the relationship between human movement and machine learning.
Okay, lay it on us.
Right now, everyday people are physically teaching robots how to navigate our messy human spaces. But once millions of these humanoid robots are successfully deployed and integrated into our daily lives, how long will it take before the dynamic reverses?
Wait, what do you mean?
Well, if a robot moves with a specific, highly efficient kinetic cadence that it learned from a composite of global data, will humans unconsciously start mimicking the machines?
Oh, wow.
With our own future muscle memory and architectural designs eventually evolve to accommodate the very robots we originally taught how to walk.
That is an incredible concept to end on. We are shaping the machines now, but eventually they might shape how we move through our own world. Well, that is all the time we have for our deep dive into the unexpected realities of embodied AI. Thank you so much for joining our conversation and unpacking this incredible technological shift with us. Until next time, stay curious and keep exploring.